today you are going to be learning about waves. And you're going to be learning about how waves can be in and out of phase, and by how much, and how can we calculate how much they are in and out of phase by. Okay, so what we've got here at the moment are two waves set up. We've got this nice green wave, and I can change the wavelength of this wave by dragging it. This is in Data Studio, so you guys can also do this. You just need to click on Sound Creator and it comes up. You can also change the amplitude of this wave, or you should be able to. There we go. I'm going to leave it maximum amplitude. Hopefully that means you can hear the sounds that I create as well. Now, we've talked a little bit about this before, so I can move my wave so that I'm getting a different wavelength, and I can make it exactly the same as the red wave. So at this point, you can't really see very clearly. You've got the red wave and the green wave that are completely, exactly in phase. They've got exactly the same wavelength, exactly the same frequency, exactly the same amplitude. And down here, what this is showing us is what the combination of the two waves creates. So we've got two troughs coming together, we get a mega trough. Two peaks coming together, we get a mega peak. I can fiddle around with this so that I can get them more out of phase or in phase. If I click here, then you can see what happens over time. I've changed the scale. So at the start, it looks like they're pretty much in phase, but because they're very, very, very slightly out of phase, because one of them's got a slightly different wavelength, then the amount that they are out of phase over time becomes bigger and bigger until we get them completely out of phase around this point here, and we get what you could think of as a node. And over here we've got our antinodes. So if we play this sound and listen to it, we should hear what we call beats. So it gets loud, quiet, loud, quiet. It's probably going to be quite a high frequency, so it will probably be quite quick. Let's have a listen. And you can see the waves getting in and out of phase and how they start to cancel each other out. And this is the resultant waves. So now you want to know by how much they are out of phase. Well, we could just say these are totally in phase or these are completely out of phase. However, we're scientists, we're physicists, and we want to be a bit better than that. So now we need to think about waves in terms of circles. So this is, you'd probably agree, a sine wave. And sine waves, hopefully you know, can be related to circles. If you don't believe me, I'm going to show you, hopefully, just how that can be true. So on here, we've got a nice device that will move around. And as it moves around, it makes the piston go up and down. Let me show you. Okay. As this piston goes up and down, it looks like it's just doing something really boring. But if you look at the beads that are connected to it, you can see that they start to create a wave. I'm going to increase the frequency just so you'll see it more clearly. We're getting waves being created, okay, as the frequency goes up and down. And you can see that's all because of this point turning around in a circle. Okay, oh darn. Try and get it stopped at the top and never get it. I'll put the frequency down. It just makes it a bit easier for me. So I'll get it started. Oh, that's slow. Oh, too slow. Let's go a bit faster. Okay. Right, at this bottom point, oh, that'll do. This bottom point here, we've got a minimum. We've got a trough. And you'll see that if we count this as our starting point, we could say that this has moved 0 degrees in terms of a circle. It's moved 0 degrees. And if we let it go, so it moves 180 degrees, at 180 degrees, it is now at its maximum. We've got a peak occurring here. So if we had two waves that were totally out of phase, can I get my waves back again? So that would be like having a peak and a trough together. So remember, when we've got a peak and a trough together, they completely cancel out. So we get cancellations here. So we could say these were 180 degrees out of phase, because if we look back at our circle again, that's when we had a peak and a trough would be if they were the circle and the piston was at the top and at the bottom. Let me get it back up for you again. So if we'd have to have two pistons, one where the circle, this point here was at the top, and another where this point was at the bottom, and then we'd have two waves completely out of phase. If they were totally in phase, then we could say that that would be a peak and a peak occurring at the same time, or a trough and a trough. Then for a peak and a peak to occur, they'd both have to be here, and so they'd either have 0 degrees difference or 360 degrees difference. We could write it either way. Pardon me. And that's when we get constructive interference. Now, you may have also heard it being talked about in terms of radians. Now, radians is a little bit more confusing. What are radians? You may want to think about. So, this is the radius of a circle. And you can do this at home. Draw out a circle, any size circle, whatever you like. And then cut a piece of string so it is the same length as the radius. So remember, the radius should go from the center out to the edge of the circle. With that piece of string, mark on where you start with the length of the piece of string to the end, and keep going. Keep moving your piece of string around. Oh, I don't know how to turn this. Around it, and marking on where it joins, where the next place is. Keep going around and around and around until you've marked out, and you can count how many radians or radial lengths fit in one circle. You should find that it's just over 6. In fact, it's exactly 2 times pi radians in the circumference of the circle. You've probably used that formula loads of times. The circumference of a circle is 2 pi r, but you've maybe never really thought about where it comes from. So that's what it means. So in one full circle, we've got 2 pi radial lengths. So that means in half a circle, we'll just have pi lengths. Remember, that angle is equal, so half a circle is equal to 180 degrees. So we could say 180 degrees is equal to pi radians, or 360 degrees is equal to 2 pi radians. So if we go back to here again, instead of talking about this being a 0 degrees difference, we could say 0 pi difference, so 0 pi out of phase. At this stage here, if we had a peak and a trough, it will have travelled pi radians. So it would be pi radians out of phase, or 180 degrees out of phase. Right, hopefully that's made it all a little bit clearer, and I'll email you some more links to help you understand. And now I just need to turn this video off somehow.